Okay, hi friends, welcome to our channel. Today we are going to continue our topic, class 11 chemistry, chapter 1 atomic structure. After we discussed about the characteristics of electromagnetic wave, that is completed. Okay, now let us continue our new topic, black body radiation. Okay, so for first of all, what is meant by a black body? Black body is not something the body with any object with black color. Not all the black body should be in black color. Some of may be in black color also. The ideal body which emit energy, which emit the radiation and absorb the radiation is called black body. The ideal body, okay. Only some of the bodies can emit energy continuously or absorb energy continuously. Those ideal bodies are called black bodies. Here energy means radiation, okay. The radiation emitted from a black body is called black body radiation, okay. The radiation emitted from a black body is called black body radiation. Now, there is no perfect black body in nature. There is no 100% black body in nature. Only 99% carbon black is a black body. And also platinum black coated with metallic hemisphere which have a small hole present in it. Those are black bodies. And they behaves like a black body. Okay. There is no perfect black body in the universe. Here we are seeing one diagram. Right, this is a black body. Let us assume that this is a black body. So the incident radiation absorb a black body and these are the emitted radiation. They are absorbing the energy and they are also emitting the energy. Okay. For example, see sun is a black body, right? It is also emitting light with different wavelengths and they have different frequencies, right? Yeah. Now see a graph is drawn between wavelength and intensity of radiation. Now see how the graph behaves. First of all, the graph will come like a slope. Will have to come like a slope, but it does not come. When the scientists are observed a graph should become like a slope. But what happens is the graph came like a shape of parabola, right? Inverse parabola. The intensity of radiation depends on the temperature of black body. Yeah, the temperature of black body. See, when you observe the graph, the x-axis is the wavelength and the y-axis is the intensity of radiation. Okay, the x-axis is the okay. When we see the x-axis is the wavelength and the y-axis is the intensity of radiation. The intensity of radiation, what happens when the temperature is increasing, the intensity of radiation also increasing. When the temperature is very less, when we see 3000 kelvins, the intensity of radiation also very less. So at given temperature, as wavelength increases, intensity of radiation also increases, reaches maximum, then decreases. At particular temperature and as wavelength increases, see when the wavelength increases from 2000 to 4000, 6000, it is increases, the intensity of radiation increases. But when reach maximum value at the peak, when it reach at the peak, it also started decreasing and it attains a minimum value in the last. See here, we see it attains a minimum value. The highest intensity of radiation observed on moderate wavelength and the medium wavelength. When we see between 4000 and 6000, these are the very moderate wavelengths, right? The peak, the highest intensity of radiation is not observed in lowest wavelength or highest wavelength. It is observed in the medium wavelength, okay? But the lowest intensity of radiation is observed at the lowest wavelength and also the highest wavelength, okay? So these are some unbelievable results. So what the scientists observed, the scientists thought that the graph will come like a slope, but when we do the experiments, the graphs came like a parabola, inverse parabola. See, when the temperature start increasing, the when the black body radiation absorb radiation, black body absorb radiation, then its temperature also started to increase. Okay, this is keep in the mind. As temperature increases, intensity of radiation also increases, but the peak of the curve turned into lower wavelength. But see, it is turned to lower wavelength side and also turn to higher wavelength side also. What when it reaches the highest intensity of radiation. Now, a person developed a theory based on this black body radiation. The person is Max Planck. The theory is called Planck's quantum theory. This theory was proposed by Max Planck to explain black body radiation. The radiation emitted from a black body due to vibration of charged particles in the black body. How the radiation is emitted from the black body is due to the vibration of charged particles in the black body. What is this vibration? This is something new for us, right? The vibration, the charged particles. Don't worry. See, this is an atom. Observe, this is an atom, and this is a nucleus. When the electrons fall from a higher orbit to lower orbit, the energy is emitted. The energy is decreases, releases, right? So the photon is also emitted. Assume that photon here is radiation. Okay, energy. Okay, energy. Okay, energy is also emitted. See, when the electron jumps up to a higher orbit from lower orbit to higher orbit, the energy is absorbed. Okay, photon absorbed. Photon. What is meant by photon? Photon is energy. Okay, this is something similar to the Bohr's postulates, right? In Bohr's atomic model postulates, in 10th and 9th classes we studied this. It's very easy. What are here charged particles? Electrons, right? The emission of radiation doesn't take place continuously but takes place in a discontinuous manner. We see in the graph, it is discontinuous manner, right? Sometimes the intensity of radiation comes to high and sometimes suddenly decreases, right? This is in the form of small packets of energy called quantum. So this is very important, right? This is in the form of small packets of energy called quantum. The energy is released from a black body. This is in the form of a small energy packets called quantum. Let us see a sample diagram of quantum. Yeah. See, take a black body, the energy released from black body. This is in the form of quantum, small. This is a small energy packet. See, this is a small energy packet, and this is inside. This is a quantum. Okay, there's a lot of quantums, but a sample diagram. Okay, the emitted or observed radiation travels in the form of waves. See how it is traveling in the quantum in the form of waves. Okay, except the head part, the remaining is traveling like a wave. Okay, another thing that was proved in quantum theory was a Planck was energy of each quanta. The quantum is directly proportional to its own frequency. Okay, what is the frequency? The number of waves passes through a point in 1 second is called frequency. Right. Here the number of quantums passes through a point in 1 second. So frequency. So it is that the energy of quantum is directly proportional to the frequency. If E represents the energy of quantum and V represents the frequency, then E is directly proportional to V. Okay. Let us take E is the energy of quantum and V is the frequency. Now E is directly proportional to V. So E is equal to HV. H is called Planck's constant. Okay. Whenever there is a directly proportional, we have next step is a constant. Now H is called Planck's constant. The value of Planck's constant is 6.625 or 6.626 into 10 power minus 34 joules. Or we can say 6.625 into 10 power minus 27 x per second. C is used. Then the unit of Planck's constant is joule second inverse. We know that the frequency is a speed, like E is equal to hv. What is V in before video formulas, 3 formulas? We know that V is equal to C by lambda. So substituting in place of V C by lambda, we get E is equal to hc by lambda. Okay, where lambda is the wavelength of the quantum and the C is the speed of light in vacuum. It is same for any wavelength. Okay. Now E is equal to hc by lambda. When we divide those into two parts, E is equal to hc into 1 by lambda. 1 by lambda is nu bar, which is wave number. That is also we discussed in before video. The total amount of energy emitted or absorbed by any particle is an integral multiple of hv. The total amount of energy is emitted or absorbed by any black body or any body is in the form of small integral multiples of whole numbers. E is equal to n hv. N is called n. The value of n should be 1, 2. Okay. See, the value of n should be 1, 2, 3, like the whole numbers. They should not be in the 1 point like decimals, okay? Okay, where n is the whole number. Okay, understood. Yeah, this is the Planck's quantum theory. The Planck's quantum theory was completed. The main point is the Planck quantum theory is the energy is released or absorbed in the black body, which is the energy is in the form of small packets. The energy is absorbed by a black body. This is in the form of small packets, which is called quantum is singular quantized plural. Okay? Yeah. Now Einstein approach. Einstein modified the Planck's quantum theory. He said he does not say that Planck's quantum theory is wrong, but he some modified the Planck's quantum theory. Let us see the modifications. Energy released in the form of small energy packets called photons. What we studied is quantum. Now what he said is photons. Okay, and energy released in the form of photons or propagates in the form of photons. It does not propagate in the form of wave. We studied that quantum propagates in the form of wave, but here the photons is propagate in the form of photons only. Okay, you know what? Now an important conversion. Okay, if lambda is in angstroms, so maximum in the graph also if you observe the wavelength is in angstroms. So what we can do when the wavelength is in angstrom, then the energy of radiation should be 12,400 by lambda, which is in angstroms. Okay, and the one important we will notice that the energy of radiation is the value. When we divide the value, we will get the energy of radiation in EV units. See, when we see observing in the bracket EV units, right? Then the energy is in EV units. What happens when the answer is in joules? Yeah, we can convert in the joules. When we multiply the answer with 1.6 into 10 power minus 19, then we get the answer is in joules. Okay, and easy conversion. Okay, we no need to worry. Yeah. So if the question is asked in lambda, we can directly substitute. But in the question, the wavelength is asked in angstroms. Wavelength we have so many units, right? Nanometer, angstrom, centimeter, meter, like so many units we have. The wavelength is asked in what angstroms, then we have to divide that with 2400. That too we get in EV units. When we convert joules, we should multiply with 1.6 into 10 power minus 19. Okay, this is also helpful in distance of closest approach. The problem they will do in MEV units. What we have to do when to convert in EV units, we will multiply with 10 power 6. 10 power 6 E. Okay, the beside we should write E, and upper E square one E should cancel. Okay, that's the process you can. Yeah, this is our today's class. Hope you enjoy. Hope you enjoy this class and understood this class. Please like, share, and subscribe. Thanks for watching, and let's meet in the next session.